Hello, thank you so much for joining, whether you're joining now live or joining us later on. Thank you so much for joining. We received so many questions today, so we're excited to be having our experts today from the Coral Restoration Foundation. They should be on the box next to me. If you're having any issues with the playback or anything like that, please reach out to stemCONNECT and our team, and we'll make sure that you are connected and are able to actually watch this. If you are online and have any issues, you can also submit them through the question panel, even in the recordings. Over off to the side, there should be a little box that says questions. Just type your information there. It'll send it directly to our team, and we can get in contact with you right away. With that said, I'm going to go ahead and pass it off to the Coral Restoration Foundation, and I will be in the background if there's anything needed.
Cool. Well, thank you. My name is Thomas.
And I'm Addison.
And we are both interns here at the Coral Restoration Foundation. So we're excited to have you guys, and we hope you get something out of this presentation. All right. So first and foremost, a coral is in fact an animal. So I know they can look like plants or even rocks at times, but these animals have been around for over 500 million years. And they persisted in shallow seas for that long, but they've actually been identified to be older than some dinosaurs. They're one of the oldest animals on Earth, and they actually form one of the most biodiverse ecosystems on the planet that we call coral reefs. Coral reefs provide a myriad of ecosystem services. And take a good look at this photo, because this is actually a representation of a species of coral we call staghorn. And this is it's formed into what's called a thicket. So this is a really pretty formation of these corals. We're going to do a little bit of a comparison slide for you guys. So not to be too dark, but this is kind of what we've been seeing a lot here in the Florida Keys now. This is called a rubble field. And since the 1970s, reefs around the world have degraded very rapidly. And coral reefs are one of the most threatened habitats on Earth. So staghorn corals are in a group of corals called stony corals, and they're some of the most at-risk group of animals facing extinction today. So let's talk a little bit about coral reefs and their value. At least 500 million people rely on coral reefs for food, coastal protection, and livelihoods. The global value of coral reefs is estimated to be almost $10 trillion as well. And going on the coastal protection piece, I know this particular presentation is catered to hurricane protection, and we'll get a little bit more detail in the slides to come. All right. This is what used to be an elkhorn colony. It's one of the other corals that we work with. And this formation that you're seeing, kind of that triangle or that Y shape there at the top, is kind of a remnant of what used to be a healthy coral colony. We've lost 50% of the world's coral reefs in the last 30 years. And it's anticipated that by 2100, or within the next 80 years, all shallow water coral reefs could become extinct. Remember those 500 million people that were supported by coral reefs and the billions who indirectly kind of benefit from it. Those people will all be affected if coral reefs go extinct. Oceans provide over 75% of the oxygen that we breathe. So if that ecosystem collapses, think about how bad that could be for us. And that could affect all of those people's lives that depend on them directly and indirectly. So a little bit about Florida's coral reef. It can also be called the Florida Reef Tract, but it stretches 360 miles from Martin County, which is on the east coast of Florida, to the Dry Tortugas National Park. So that's what this image is kind of representing. But you might not know that it's the third largest barrier reef in the world, and it's right here in our own backyard. So if you guys were here in person, we would ask a question: do you know what the other two are? So I'll give you 5 seconds to think about it. We'll try to make it like an interactive presentation, but the most common one that people remember is the Great Barrier Reef that's off the coast of Australia. And the one that's hardest for people to remember is the Mesoamerican Reef, which is off the coast of Belize in Central America. All right, as I mentioned earlier, Florida's coral reefs provide a multitude of benefits. So contrast to the previous images, which were dead corals, this is a healthy elkhorn coral colony, and you can see there's lots of fish and other kinds of abundance surrounding that. These coral reefs provide coastal infrastructure from storm surges and flooding, also related to hurricanes. It's also a habitat for fish, which helps with recreational and commercial fishery yields, so the ability to catch more fish if there's more habitat, more homes for those fish. And the entire Florida Keys really is a tourism industry. Scuba diving shops and fishermen are kind of what we see out here. There's kind of a joke that there's more dive shops than gas stations in the Florida Keys, which is actually true. So in addition to protecting our coast from storm surges and creating habitat, it really is the foundation for us humans and the life that we can live out here in the Florida Keys. Alrighty, so sadly, Florida's coral reefs are under threat. In the last 50 years, the coral cover has declined almost 97%, which is a significant number. And the reef building species that we here at the Coral Restoration Foundation work with the most are elkhorn, which is represented in this photo, and staghorn, which was the one from one of the first photos that looked more like branch-like coral. All right, again, if you were in person, this would be a little bit more of an interactive slide, but this is designed to kind of break down the differences between what it looks like at the coastal level, both under the waves and on the land that we live on when there's a healthy coral reef near the coast. So you can kind of look at both of these and identify the differences. So we'll actually point some out here for you. The most obvious one is that there's no mangroves in the degraded coral reef image that's on the bottom. Mangroves reduce storm surge significantly from things like hurricanes. So those waves now are more in contact with the local shores right there where like people end up living, which is a direct impact to humans. But also if you look underneath the waves, there's less dolphins, there's less fish, there's less actually on that big rock structure. Those are all supposed to be representative of corals. There's a lot less than that people can get from actually fishing, so a lot less food for people, and corals do actually reduce a lot of the energy from waves and from storms as well. So hopefully you guys can take a look at those two images and kind of identify the differences for yourselves if you guys are taking a look at this presentation.
Okay, hi guys. So I'm going to talk to you a little bit about the local stressors that the coral reefs are facing, particularly down here in the Florida Keys. So to start, we have direct human impact. So diving is one of the biggest sports around here. So as a diver, it's important to have good buoyancy so you're not kicking the reef, and as a snorkeler as well. Making sure that you don't collect souvenirs such as seashells or pieces of coral that you find is important as well. For anchoring and boating practices, you know, people can come down from Miami and rent a boat and they don't always exactly know what they're doing. So sometimes that can have an impact on our coral reefs. And so these interactions have resulted in the destruction of our reef structure over time. So another threat that they're facing is the disappearance of herbivores. So in some areas, there's unregulated fishing practices. So that means that the herbivores are being overfished. In the 1980s, there was a disease event that wiped out the population of long-spined sea urchins, which they are important because they feed on algae. And so algae and corals are competitors in that they fight for space. So when there's no sea urchins eating the algae is able to take over, and which reduces the amount of space that the corals can have to grow. So the Florida Keys is a beautiful place and a lot of people want to live down here. And so as a result, we've had rapid development become an increasing problem over the past 50 years. It's resulted in nutrient runoff and sedimentation from all the construction going on. In the 1990s, there was a whitepox event that resulted in 90% mortality of elkhorn coral. And this was linked directly to the degradation of water quality from this urban development. And so finally, this is something you may not think about, but the chemicals in your sunscreen do make a difference. So a lot of sunscreens contain harmful chemicals such as oxybenzone, avobenzone, and octinoxate, which if they come in direct contact with corals can be harmful. So don't throw away your sunscreen. If you do have sunscreens with these ingredients, you can use them at the pool or whatever, but just be sure that if you're going to the beach, just check the ingredients in your sunscreen. And so, as we all know, one of the biggest global stressors facing our generation is climate change. So climate change is a result of the increased gas emissions because of increased industrialism. And this has resulted in ocean warming and ocean acidification. And so ocean acidification, because of the increasing pH of the waters, because it's absorbing the carbon dioxide, it's resulted in coral bleaching. And this is important because it impacts the coral's abilities to grow and maintain their calcium carbonate structure. So the corals aren't able to build upon themselves and create that necessary foundation that coral reefs need. So climate change is anthropogenic, and it presents the biggest threat to our world's coral reefs. And so I know Thomas talked a little bit about our two species that we mostly focus on, our Acropora cervicornis and Acropora palmata, also known as staghorn and elkhorn. But we also have two species of boulder corals, as you can see in the picture on the bottom. On the top is staghorn and in the middle is elkhorn. We focus a lot on biodiversity because it's an important aspect of the health and resilience of an ecosystem. And so in our nurseries, we have a total of 20 different species. And so to grow our corals, we use this method called propagation, which if you've ever worked with plants, you may be familiar with the term, but essentially it works the same way. Essentially, we have these corals that we grow on trees, and then once they go from about this big to this big, they reach full maturity, we just cut off a piece of them, and then we take them back to the reef. So our first corals initially came from healthy wild colonies, but at this point in time, we are completely self-sufficient, and all of the corals that we outplant onto the reefs come from our nurseries. And some of the genotypes that we have in the nursery no longer exist in the wild. And so far we have returned more than 170,000, I think it's up to 180,000 corals we've returned to the wild, which is amazing. So here you can see the impact of what we're doing. Here's one of the reefs that we outplant on, Carey's Fort Reef. You can see elkhorn outplants after 9 months on the reef in 2017. And these are on the right, you can see the same outplants just 2 years later. So you can see that what we're doing is working. And so what can you do to help us? So there's many different ways to be an ocean steward. These are just 8 of them. And so yes, there's a lot of them. You don't have to do all of them, but I invite you to choose just a couple to commit yourself to, such as reduce your carbon footprint. You could carpool places, use reef safe sunscreens, which is an easy fix. Maybe rethink your diet and food waste. I know being a vegetarian is a very eco-friendly way to make a difference. And so yeah, most importantly, spread coral reef awareness. Tell your friends all this information. And so yeah, that's it.
Thank you.
Awesome. And now there should be a short video that is going to play. All right. Awesome. Now we have some questions that were submitted prior. The first one, we'll start off with the focus on hurricanes. They were wondering if it's possible to completely stop a hurricane by the use of growing coral.
Wow, that's a big question. I think the immediate answer is no, it can't stop a hurricane. With corals being underwater, they can have an impact on what we call wave energy. So when a hurricane is kind of spinning, you'll see if you look at a radar, it looks like it's almost spinning. It's not something you can see usually when it's in the sky. Hopefully you're not near a hurricane, but the waves that it produces have a lot of energy and they can wash up onto shore in areas where normally the waves wouldn't reach because they're powered by the hurricane's winds. And corals, if they're a healthy coral reef, it can create kind of a barrier. We talked about that barrier that the Florida Reef Tract actually is, and it can reduce that wave energy. I think the number is somewhere in the high like 80s or 90%.
It's 97%.
97%.
Yeah.
So it's very significant, and that can really reduce the amount of damage it does to homes and roads and vegetation. Mangroves also do a really wonderful job in reducing wave energy. So in combination, we would like to restore coral reefs and mangroves as well, because they both can really help with storm surge and with wave energy that comes alongside a hurricane. But there's no way to actually stop a hurricane in its tracks.
With bigger hurricanes and storm effects, do you have to worry about the harsh impacts potentially on coral?
Yeah, so that was a little bit in the article that you just sent me, if you want to talk about how that specific one.
Can you ask the question one more time?
Yeah, so I think this is a high school class because they're curious about with bigger hurricanes and the storm and stronger storm effects, if there will be harsher impacts or if you have to worry about the impacts on coral.
Yeah, that's actually a good question. So the process that we use when we talk about propagating our corals is actually something that should occur naturally. It's an asexual way of reproduction. It's called fragmentation. So stronger storms can actually break the coral branches off, and those pieces will float off in a current or find a different place on the reef and kind of like land in between rocks, and they can settle there, and they can also grow from that. So with the increasing intensity of storms and with kind of the increasing number of storms that we've been seeing, especially in the last like 5 or 10 years, hurricanes can actually almost assist in the way that corals can kind of reproduce and propagate in different places. But it is something that if, you know, those corals are young and maybe not as healthy and they break, perhaps they settle in an area where, you know, it's more sandy. That's usually somewhere where it's not going to grow. That's the best way I can think about answering that question, unless you can think about.
Yeah, I mean, I was also reading an article last night that hurricanes can actually also help corals by, well, it depends on the storm. You know, each hurricane acts differently. Some collect the warm water, some cool down the water. So when that cooling does occur, especially in the summertime, like right around now, the cooling water can actually help mitigate coral bleaching, which helps our corals. So yeah, I think it just depends on the storm.
That's so cool. So one of our most popular questions we always get for Coral Restoration Foundation is how can students help save coral?
That's a good question. It kind of goes back to the slide that Addison took. If you want to touch on that.
Yeah, so I talked a little bit about it on, I think, the last slide. There's just like little things you can do, which, you know, choosing sustainable diet, reducing your carbon dioxide outputs, little things like that, and just learning more about coral reefs, you know, learn all the info that you can.
Yeah, just remembering that everything's connected. So even if you don't live immediately close to a coral reef, if you live somewhere in the middle of the United States, you know, understanding that maybe what you grow in your yard, and then if you water that or there's a rainstorm, that stuff runs off into the drains and it eventually drains into freshwater or rivers or streams, which eventually all find their way to the ocean as well. So you can kind of do little things wherever you live really in the world, and it can have a big impact on the environment because the environment's all connected.
And then we have some questions about your career. Did you have to know how to dive to be able to work with the Coral Restoration Foundation?
Yeah, you do. You have to have at least an advanced certification to work with Coral Restoration Foundation. Most people are above rescue So yeah, you do have to have diving experience to work here.
Yeah, so much of the work that we do is actually underwater. We have a nursery with 500 coral trees, maybe more, and there's several of these nurseries all the way from the northern part of the Florida Keys down to Key West. So we're constantly, maybe even 4 or 5 days a week, spending hours underwater working on these trees, cleaning, doing maintenance, and then actually planting them back out onto the reef. So it does require you to be a scuba diver, but that's not a limitation. If there's people that want to get involved with the Coral Restoration Foundation, we do dive programs, or even snorkelers will take you out to our nursery so you can kind of snorkel around and see where we grow our corals. Or we'll take you out as well to one of our dive sites where maybe we've done a recent outplanting. And you can see kind of our new like baby corals that we've put out on the reef. But if you do get scuba certified, you can join us on our dive programs. And the best way to find us really is to go to coralrestoration.org, our website, and use the Get Involved tab that's at the top, and you can find out all about helping us out.
That's awesome. And then what are your degrees and what are you hoping to do with them?
Okay, so I just graduated from the University of Miami this past May with a bachelor's degree in ecosystem science and policy. So I wasn't marine science focused. I just ended up doing it because I love to dive. And I'm still figuring out what I want to do with it. I'm just kind of going wherever I go.
I come from a different world. I got a degree in studio arts and graphic design, and then I went back to school to get my master's in marine biodiversity and conservation. And this internship that Addison and I are both in like our 5th month of, I think can go for a total of a year if we decide to stick around for all of it, which we're having a ton of fun. But it's never too late for you to switch up, do something completely different from whatever your degree is. So don't let that be a limitation for you. There's opportunities all over the place, and you just kind of follow your heart and your passion, you'll find the right thing.
That's so cool. And just as a follow-up question, because I know students will be interested, we have lots of students who are interested in the arts. So what made you switch over to science?
Oh my gosh, that's a big question. I worked for almost 10 years, and I decided that the work that I was doing wasn't fulfilling enough, and I wanted to make a change. And I'd always kind of loved, I've been lucky enough to go to coral reefs and snorkel around, and I wanted to actually make an impact knowing that they were at risk. And so going back to school to kind of learn more about, what I can do was a big influence for me. And then I was happy that I landed here at the Coral Restoration Foundation as like kind of a first step.
That's so cool. Well, that was all the questions we got. Thank you guys so much. It's always fun to hear about your own career paths and everything. So that was really awesome. Thank you so much for sharing. We'll definitely send out this recording. If anybody out there who's watching, if you have more questions, don't be afraid to send them to us at stemCONNECT. Hopefully maybe we can either get you connected or get you some answers at least. But definitely submit any questions that you may still have, or if you'd like to do another connection in the future that works better with your class time, definitely send in a session request. Those are always available. Thank you guys so much for presenting today. We appreciate it so much. It was a great topic, and we look forward to talking to you guys again.
Thank you. Thank you for having us.